So let's start with some of the basics for completing the square by considering what we actually mean by a perfect square trinomial. So if I start with a simple binomial like x plus 3 and I square it, the pattern says I have the square of the first term twice the product of the two terms. So 3 times x, double that, gives me 6x. And then the square of the last term, plus 9. So that's how I square a binomial. And in the reverse, if I were checking if a binomial is a perfect square trinomial, I would be asking myself the question, is the first term a perfect square and is the last term a perfect square? Well, in this case, yes. I have x, and the square of 16, the square root of 16 would be 4. So then I would check that, is x plus 4 squared going to result in x squared plus 8x plus 16? And in fact, it will. X squared twice the product of x and 4 is 8x, and the square of the last term would be 16. So this lends us the question, what if I have just two terms, like x squared plus 12x, and then I'm wondering, what's the last term, or the constant I would need to put here so that this would be a perfect square trinomial. The other way of asking that question is, if I have x plus something and I'm squaring it, what is that something going to be so this becomes a perfect square trinomial? Well, if we look back at these first two examples, and we see that this value of b, which is 6, and how does it relate to that value of 3? Well, that seems to be half. And then here, 4 is half of 8. And then the last term, in this case 9, is half of this 6 squared. This 16 is half of that 8 squared. So if I follow that logic, half of 12 would be 6. And if I square that, that would be 36. So my conclusion is that x squared plus 12x plus 36 is a perfect square trinomial. That would factor to x plus 6 squared. This works similarly even if you have a middle term that's negative, x squared minus 10x plus something. Well, that something is going to be half of the middle term, the coefficient of the middle term, squared. So half of negative 10 is negative 5. If I square it, it means this should be 25. And then inside my parentheses for the binomial, it would be half of this. So negative 5 squared. If we multiply it out, we'd get square of the first term, twice the product of the two terms, and square of the last term. Voila. So this is the root of what we need to understand before we can use completing the square for solving equations. So if I take this same piece that we started with up here and put it into an equation, let's say I have x squared minus 10x equals 11. Well, I already know that I need to add 25 so that this is a perfect square trinomial. And since it's an equation, I'll have to add 25 to the other side as well. So now I have x squared minus 10x plus 25. 11 plus 25 is 36. I don't want to write this as a trinomial because it's a little bit easier to take the square root if I write it as a square. So if I write it as x minus 5 squared, and then I've got 36 over here, now I can use what I learned about square roots and take the square root of both sides. Square root of that side, square root of the right side, plus minus, plus minus. Don't forget the plus minus. Don't forget plus minus because I need both the positive and negative roots. The square root of the left side gives me x minus 5. Square root of the right side, plus or minus 6. The next step, add 5 to both sides, giving me x equals 5 plus or minus 6. So there are two solutions, x equals 5 plus 6, or x equals 5 minus 6, giving me x equals 11, or x equals negative 1. Let's jump up to the top and check these solutions really quickly. So here's my original equation. If I replace x with 11, I have 11 squared minus 10 times 11 equals 11. 121 minus 110 equals 11. 11 equals 11. That works out. So let's try the negative 1 solution. Negative 1 squared minus 10 times negative 1 equals 11, giving me 1 plus 10 equals 11. Well, 11 does still equal 11. Check. X squared plus 6x equals negative 8. So following along with what we just did by finding the missing number for completing the square, we'll be doing the same thing. B is 6, and we're looking for half of B. In this case, half of B will be 3, and then we're going to square it. So on the left side of the equation, we'll be adding 3 squared, and on the right side of the equation, we'll be adding 9. The reason I'm writing it as 3 squared is so that when I write the binomial squared, I'm just going to be using the half of the B value, x plus 3 squared. On the right side, I'm simplifying it into 9, so then I can add it to that negative 8. So negative 8 plus 9 will give me 1 on the other side. Now that I have the equation written out, I can solve it using square roots. X plus 3 quantity squared equals 1, and I can take the square root of each side. Remember, when you take the square root of the right side, use the plus and minus because you want both the positive and negative root. On the left side of the equation, when I take that square root, I'm left with x plus 3, and on the right side, I have plus or minus 1. The next step is fairly straightforward, but be careful. It's easy to make a careless error with this. We will be subtracting 3 from both sides, giving us x equals negative 3 plus or minus 1. That means there are two solutions for this equation. There is x equals negative 3 plus 1, and x equals negative 3 minus 1. So in one case, we have negative 2, and in the other case, we have negative 4, the two solutions to this quadratic equation. Checking the solutions, negative 2 squared plus 6 times negative 2 equals negative 8. If we go through the arithmetic here, we will see that in fact negative 2 is a correct solution. Similarly, we will try x equals negative 4, the second solution. So negative 4 squared plus 6 times negative 4 equals negative 8. And once again, as we go through that arithmetic, we will see that both solutions do in fact work for this quadratic. And the last example to take a look at is x squared minus 8x plus 13 equals 0. So unlike solving an equation by factoring or graphing, for completing the square, we don't want the equation equal to 0. We actually want the constant isolated by itself on the right side of the equation, leaving x squared minus 8x, or the terms with the variables, on the other side of the equation. So subtract 13 from both sides, giving us the next equation, x squared minus 8x equals negative 13. Now we're going to go through the same questions, asking what do we need to add to both sides to make this a perfect square trinomial on the left. So the value of b is negative 8. We'll be looking at half of that value squared. So half of negative 8 is negative 4. On the left side of the equation, I'm going to write it as negative 4 squared because it's the negative 4 that I'll be using when I write the binomial. On the right side of the equation, I'll actually square it and write it as 16. So on the left side, x minus 4 squared is what I will end up with. And on the right side, it'll be negative 13 plus 16. So you see that inside the parentheses, I'm using half of that b value, getting me the x minus 4. When I square it, that gives me the 16, which is the number I need to add to both sides of the equation. Once I have this written out, I can continue solving. So now that I have x minus 4 quantity squared equals 3, I can follow up by taking square root of each side. And remember, use plus minus because we need both the positive and negative roots of that constant. On the left side, I have x minus 4. On the right side, I have plus or minus the square root of 3. And I'm one step away from a final solution for this, adding 4 to both sides of the equation, leaving me with x equals 4 plus or minus the square root of 3. This is the simplest radical form solution, or solutions, if you will, for this quadratic equation. But perhaps I might need to use these values to solve a problem, and maybe I need the solutions rounded to the nearest hundredth. So x equals 4 plus or minus the square root of 3 to the nearest hundredth is about 1.73. So that leaves me with these two solutions. So here for the next part, we're simply adding these numbers on this side, giving me 5.73. And for the other solution, 4 minus 1.73, let's see, that'd be 2.27. Hope one of you out there is checking my mental calculations on that, but I'm pretty confident with it. So once again, two solutions, and that's completing the square.